Yangtze River in China rises the biggest concrete structure on the planet. The Three Gorges Dam is over 2 kilometers long and 60 stories tall. It has taken 40,000 workers over 17 years to build. When it fully comes online, this one dam will produce over 20,000 megawatts of power, twice as much as all the nuclear power stations in Britain put together. It is the pinnacle of dam engineering. China is one of the fastest growing economies on Earth. To fuel the need of its ever-accelerating industry, the nation needs more power. Much of this will be provided by an enormous dam spanning the mighty Yangtze River in central China, called the Three Gorges Dam. Our cameras have been granted privileged access to capture this amazing feat of engineering in its full glory. Before they could start building the Three Gorges Dam, the Chinese first had to divert. Dam.And Dam had 1 generator. Three Gorges has 32. Together they produce 5 million times more power than Dam.And. To drive them, the Chinese have harnessed the power of the mighty Yangtze River. In the reservoir behind the dam, the river now rises up to 60 stories above the riverbed. The water is channeled down gigantic concrete tubes towards the generators. Here, the torrent of water hits the turbines and makes them spin. This motion is in turn transferred to the rotor of the generator. This is fitted with massive magnets, which move past copper coils in the casing to generate electricity. Just one of these machines makes as much electricity as a small nuclear power plant. All 32 generators together produce enough power for 60 million Chinese.
This project is setting a new benchmark in the international hydroelectric industry. It's almost twice the size of the next largest project, Itaipu in Brazil. And of course, it's only the first of a whole series of megadams that are under construction here in China.
The Yangtze River is over 6,000 kilometers long, and in places several kilometers wide, the biggest river in China. It presents enormous logistical challenges to the dam engineers. As the Yangtze rises behind the Three Gorges Dam, it will flood over 150,000 acres of land along its banks. So the Chinese have to relocate over 1 million people from the land behind the dam. Thousands of new houses have to be built for the displaced citizens to live in. Then the engineers can begin to dam the river.
We're standing here among some of the rocks and these precast concrete blocks that we use to create the cofferdams to control the river during the construction of the Three Gorges project. Controlling the river to allow the construction of this huge project was clearly a major undertaking. I mean, the Yangtze River is one of the largest rivers in the world, very fast, very deep. So building these cofferdams and to allow a safe construction was a major operation. The Chinese claimed that this was the largest and most difficult diversion ever undertaken for a hydroelectric project, and if you look at the scale of it, they were absolutely right. This was huge.
The engineers begin work on a series of stone cofferdams to block off part of the Yangtze, whilst leaving a channel open for the rest of the river to flow through. They build the first two sections of the main dam on the dry riverbed. Then they dump tons of earth into the river, and on top of it build another cofferdam, this time from concrete. With the river held in check behind it, they can finally build the last section of the dam. Then they must remove the cofferdam so that water can flow through the turbines of the main dam. What has taken months to build takes only seconds to destroy. As the cofferdam crumbles, it unleashes the water stored behind it. It's the final test for the Three Gorges Dam, and it holds. The Three Gorges Dam takes concrete construction to new heights.
You look at it, you can just picture the thickness of the concrete at the base of the dam, the height of it, 180 meters, and it's 2 kilometers long, so it's a colossal amount of concrete.
Three Gorges uses 10 times more concrete than the Hoover Dam, so the engineers have to pull out all the stops to keep their dam cool.
They basically used everything in the book. They cooled the aggregates and the materials, the sands, before they put it into the mix. They added ice. They did everything they could to get the temperature down as low as they could before it started to warm up all by itself. And here, because of the issue of some of the summer weather being especially hot, July and August, they actually went so far as to use a fog spray system to blow effectively a fog blanket over the top of the dam, with the objective of blocking the solar radiation from piling down into the concrete and adding to the heat that was being generated on the inside.
But all these measures to stop concrete from cracking will count for nothing if the dam is built on weak foundations, as civil engineer Ed McCann explains.
While we can make the dam completely impermeable, it's rather harder for us to make the riverbed impermeable. Now, of course, once the water is up behind the dam here, there's a huge pressure pushing it this way. And whilst the dam won't let the water through, the water simply just goes underneath, and that means you haven't got much of a dam. There is a solution to this, and if John will give me a hand, we'll have a look at it. John, put the blocks, please. What you've got here is basically a pipe network. These are a series of vertical pipes that go down into the riverbed with little holes in the side of them. And we connect them up to a high-pressure pump. Of course, it wouldn't be this, but it would be a big pump. In this pump, what we've got is a watery grout. It's just cement and water. And when that cement and the grout goes hard, it creates an impermeable barrier. Just this time, it's in the soil. So we'll have a go. Here's our high-pressure pump. So if I squeeze that really hard, there we are. And pretty much straight away, you can see the grout coming out and running through the soil and spreading out, which is exactly what we want to see, of course. And you can see in some areas it goes a long way, and in other areas it doesn't get through. That means that the soil is denser and less permeable there. But that's fine, because what you do is you drill more holes down into the areas here, and you squirt more grout in, and you keep going until you've got a continuous curtain underneath the dam. And there we are. So we have our impermeable dam on top of the riverbed, and we've created a concrete dam underneath the riverbed.
To create an impermeable concrete curtain beneath the Three Gorges Dam, engineers drive 100 kilometers of tubing down into the granite bedrock. Then they pump 200,000 cubic meters of grout into the tubes, which is squeezed into the fissures in the rock. As the grout hardens, it turns the leaky rock into a solid waterproof base for their dam. Now the Chinese engineers can be confident that the Yangtze will not undermine their dam.
Basically, the dam holds back a large volume of the water during the flood period. Here it can hold back about 22 billion cubic meters of water. And then it's released in a controlled way through this system of 46 spillway gates and these chutes that you can see below me here. The design of a spillway like this has to deal with the force of the water as it drops over 100 meters in this case here, and then achieves huge velocity at the bottom of the dam.
To deflect the force of the water crashing down, the Chinese use technology similar to the Grand Coulee. As the water levels rise, engineers open a series of gates to drain the floodwater from the reservoir. But if the water fell straight down, it could undermine the foundations of the dam. So the engineers fit the spillway with concrete chutes. Unlike the Grand Coulee ramp, which is underwater, the Three Gorges chutes hurl the water into the air. Once airborne, the water breaks up into small droplets and loses much of its destructive energy. It lands over 100 meters downstream, where it can't do any damage. So now when they open their spillway gates,